Yes, hello, can you hear me?
Yes, ma'am.
Okay. Okay, actually, I'll be discussing your test result in the next class. Of one or two paper was remaining to check. Let's continue with trigonometry. We were on exercise 8.3, I think, right?
Yes, ma'am.
Yes. Okay, how many questions we did?
Ma'am, we did 2 questions. We should start the third one.
Third. Okay. Yes, Hamna, Rida, can you hear me?
Yes, ma'am.
All right. Let's come to question number 3. It says that tan of 2a, if tan of 2a is equal to cot of a minus of 18 degree, right? Where 2a is an acute angle, then find the value of a, right? Okay, so you can convert one side, so it will be easy to convert. So I can just convert this tan 2a. Can I write it like this? Cot of 90 degree minus of 2a, right?
Yes, ma'am.
Yes, because tan of theta is cot of 90 minus of theta. So whatever you have here, 90 minus, you got it here. So if I have 2a here, so that means I have to put 2a here, right? So this becomes 90 minus 2a is equal to cot of a minus of 18 degree. And this implies that 90 minus of 2a, I mean, this implies that this angle is same as this angle. That is why you're getting it equal. So 90 minus 2a is a minus of 18. And now you can remove degree or okay, put it here. Just simplify this thing. So 90 plus 18 is equal to a plus 2a. That means 3a. You get 8 and 108 is equal to 3a. This will give you 3 and so 36 degree is equal to a. That's the answer. Fourth one is almost same. So it is saying that tan of A is equal to cot of B. Okay, you have to prove that A plus B is equal to 90 degree, right? Okay, see, this is very simple. You can convert either one side, convert tan or convert cot. Let me convert this tan. I can write it cot of 90 degree minus of A, correct? This is equal to cot of B, right? Okay, now this implies that this angle is same as this angle. So I am getting 90 minus A is equal to B, and you take A that side. So 90 is equal to A plus B. Proved. Right?
Yes, ma'am.
Okay, similarly, the next one is almost same. Fifth question also. This is given that sec of 4A is equal to cosec of A minus of 20 degree, where 4A is an acute angle. Find the value of A. Again, now we know this thing, that sec of theta is cosec of 90 minus of theta, correct?
Yes, ma'am.
So whatever I have here, this will be 90 minus. So this sec 4A, I can write cosec of 90 minus of 4A, correct? Is equal to, yeah, is equal to cosec of A minus of 20. So that means this implies that 90 minus of 4A is equal to A minus 20. Now you can simplify and find the value of A. Tell me how much is A from here?
Ma'am, 22.
Okay, check the answer in the book. I think, yeah, it's 22, right? Yes, has everybody got 22?
Yes, ma'am.
Okay. Now next question. Sixth one. So if ABC are interior angles of a triangle ABC, then show that. So you have to show this thing, that sine of B plus C by 2 is equal to cos of A by 2. Okay. See, this is again easy. Now we know that in a triangle, right? In any triangle ABC, the sum of angle is 80 degree. That we know. So angle A plus, or don't put angle, simply write A plus B plus C is equal to 180 degrees. So this is implied that A, B, C are angles, right? If you want to put angle sign, you can put, no problem. So A, B, C are, because here you can see there is no angle sign, so I'm also not writing, correct? Okay, so ABC is 180 degree. Now you can see you have A on the other side and B and C on the same side. So I'll also do this thing. So I'll keep B plus C here and I'll bring my A this side, right? Okay, now let me divide both the sides by 2. So can I do this? B plus C divided by 2 is equal to 180 degree minus of A divided by 2, right?
Yes, ma'am.
Any problem here? Okay. Now, this can be written like this, B plus C by 2. I can just separate it. So 180 degree divided by 2 becomes 90 and this becomes A by 2. No problem. This is simple like algebra. Okay. Okay. Now I'm taking sine on both the sides. So taking sine on both sides. I mean, these are actually angles, that B plus C by 2 is actually equal to 90 minus A by 2. So these are angles. Now I'm taking sine of these angles. So I take sine of B plus C divided by 2 is equal to sine of 90 minus of A by 2, right? Now, what can I write this thing? Sine 90 minus theta, that is cos theta. So this can be written as sine of B plus C divided by 2. That becomes your cos of A by 2. Any problem, anybody?
No, ma'am.
No, ma'am.
Okay, let's look at next question then. 7th. Now express the sine of 67 degree and plus cos of 75 degree.
Ma'am, one doubt.
Yes.
Ma'am, it would be minus A by 2, right?
Why minus of A by 2?
Ma'am, the 90 and 90 would get cancelled, right?
No, I didn't get
Ma'am, could you explain that last part again?
this one, right?
Yes, ma'am.
Okay, see, no algebra here. This is simple, this thing. Harsha, you know that sine of 90 minus of theta is equal to cos of theta. Okay, so whatever angle is subtracted from 90, that becomes your cosine angle. Understood?
Okay, ma'am.
Yeah, because sine and cos are complementary. So whatever angle I subtract from 90, that becomes your cos of the angle. So I'm subtracting angle of A by 2 from here. So I'll get cos of A by 2. So simply compare it with this.
Okay, ma'am. Thank you.
All right, next question. So this is saying that express this in terms of trigonometric ratio of angle between 0 and 45. So basically these angles, you can see they are greater than 45. You have to keep your theta less than 45. Understood? So you can convert, you can simply write it like this. Now again, I'm using this, that sine of 90 minus of theta is cos of theta. So whatever I subtract from 90, that will become my cos of. So 67, can I write it like this? Sine of 90 minus 23, right?
Yes, ma'am.
Just simply converting 67 as 90 minus 23. Right, Hamna? I can't hear you today.
Yes,
Okay.
ma'am.
Okay. And again, this cos of, now 75, I can write 90 minus of 15, right? So I am simply just converting these here. Okay. Now sine of 90 minus theta will become cos theta, right? So this will become cos of 23 degree and plus. Now cos of 90 minus theta will become sine of 15 degree. So you can see the angles have like reduced now. They are between 0 and 45 degree. Now, any problem in this exercise or any confusion?
No, ma'am.
Yes, Rida, Myra are you here or not? Okay, Myra is not here. Rida, any confusion, Rida, in this?
No, ma'am.
Okay. So just, keep this thing in your mind that whatever you subtract from 90, because sine and cos are complementary of each other. So whatever you subtract from 90, that will become cos. And if you write cos of 90 minus of, let's say b, so you will get sine of b. So whatever you subtract from here, you will get it here. Okay. So let's come to exercise 8.4 now. Now in 8.4, you will learn a few new things also. Identities. So far we were dealing with angles, ratios, complementary angles. Now let's come to identities. Trigonometric identities. Now what is an identity? I told in the previous class also. Yes, Hamna, what is an identity? Harsha, do you remember?
Ma'am, it's a proved statement which is already proved and we can use it to find
Yes, I mean,
other.
yes, identity means it's like always true, right? It's already proved. So you don't have to prove it. You can just use it as a result. It's proven statements. It is always true. So the three identities you have to use in this chapter are, first, that sine square theta plus cos square theta is equal to 1. So that's the first identity. So whatever the value of theta is, this is always true. Okay. Second is that 1 plus tan square theta is sec square of theta. And the third is 1 plus cot square theta is equal to cosec square theta. So these are the three identities you have to remember. Yeah, just to avoid confusion, just note here sine and cot are complementary. So basically you have to keep them on the LHS, in case you get confused. So basically this is 1 plus tan, this is 1 plus cot, which are actually like inverse of each other. And then you have like CC in both. So cot and cosec, they fall in the same identity. So in case you get confused, so 1 plus cot square theta is cosec square theta. So from CC, you can remember both common. Let's come to exercise. Then we will see how to use these identities now. Exercise 8.4. Okay. First question. Express the trigonometric ratio sin A, sec A, tan A in terms of cot A. So basically you have to convert sin A, then sin A, sec A, and tan A. You have to convert them in cot A, right? Okay, so we use the cot identity here. Now we know that 1 plus cot square theta is equal to cosec square theta, right? Yes?
Yes, ma'am.
Okay. Now, because I want to find sine, and I know that sine of A is equal to 1 upon cosec of A. Yes, Vrida? Oh, so first of all, let me find
Yes, ma'am.
the value of cosec, and then I'll take the inverse, so I'll get sine. So you can see I have cosec here, but this is square. So let me take its under root. So under root of 1 plus cot square theta becomes your cosec theta, or A, sorry, I have a habit of writing theta. I don't know why. Anyway, so cosec of A, right? Now I have got cosec, just take it inverse. So taking inverse on both the side. So 1 upon 1 plus cot square A is equal to 1 upon cosec of A, right? So this becomes 1 upon under root 1 plus cot square A becomes your sine of A. So you can see I have expressed sine of A in terms of cot A. Yes, Hamna?
Yes, ma'am.
Okay, so I have got the value of sine in terms of cot. Now, similarly, I want sec of A, right? Now, I know that sec of A is 1 upon cos of A, correct? Oh, but I don't want cos, so I think I don't even have to go here. Okay. Right, sec A directly. So use the sec identity. 1 plus, sorry, 1, what was the identity? 1 plus tan square theta is equal to sec square theta, or A, right? Okay.
Yes, ma'am.
Find the value of sec A from here. And also you have to convert this tan into cot, because I want my answer in cot. So I can do this, that 1 plus tan square A can be written as 1 upon cot square A, right? Is equal to sec square A, right? So you can take LCM this side and then under root. So this becomes your cot square A plus 1 and divided by cot square A. Yes, any problem, anybody? Here I've taken LCM on the left hand side, that's it. And then take its under root. Sorry, cot, this is cot, not cos. So cot square A plus 1 divided by cot square A, that becomes your sec of A. So you can see you have expressed sec in terms of cot, because on the left hand side you have only cot, right? So you have expressed sec A in terms of cot A. Written?
Yes, ma'am.
Okay. Now next you want the value of tan A in terms of cot only. So how to do it? Now you know this thing, that tan of A is sine of A divided by cos of A. Yes, Hamna? Or should I show it?
No, ma'am, I need.
Yes, fine. Okay, sine A by cos A. Now we have already found sine A here, and because I have found sec A, I can take it inverse. That will give me cos A, correct?
Yes, ma'am.
Okay, so like from here, it implies that cos of A will become just the inverse. So cot square A divided by cot square A plus 1 under root. So that becomes your cos A. Now put these values here. Cot, not cos. So put it here. Sine A is 1 upon under root 1 plus cot square A. Okay, very carefully. Then cos A is under root cot square A and divided by cot square A plus 1, right? Okay. So if I split the under root here, like 1 plus cot square A and divided by cot square A and then divided by under root of cot square A plus 1, right? Just I have instead of writing the whole square root, I have taken separately in the numerator and denominator. Now you can see this denominator is same as this denominator, so it will cancel out 1 plus cot square a and 1 plus cot square a. So I'm simply left with 1 upon under root of cot square a. Now you have square also, you have under root also. So this will go away. It will be 1 upon cot a only. And what is the inverse of cot a? Oh, wait. Just a minute. You have to express tan in terms of cot, right? And I'm again getting 10. So where should I stop here? Yeah, I think this is the answer, right? I'm getting the value of tan A in terms of cot, 1 upon cot A, right?
Yes, ma'am.
Yeah, okay, that's it. Okay, just note it down. Give me a minute. Yes, okay, next question now. Question number 2. Write all the other trigonometric ratio of angle A in terms of sec A. Okay, so you have to write all the...
Ma'am,
Yes.
for the previous question for tan, can we also write cot is equal to 90 minus theta? That you can use that rules.
No, with the help of identities you have to show.
Okay.
You know, actually the first question is always based upon that. It's always very direct application of whatever concept which you have started in the exercise. So because this exercise is based upon trigonometric identities, so with the help of identities you have to show it, right?
Okay, ma'am. So, but if in exam it comes, we could use that also, right?
No, that is actually you are saying that tan of A is cot of 90 minus A, right?
Yes, ma'am.
See, you are not expressing tan in terms of cot here. Here you are establishing that they are complementary, right?
Yes, ma'am.
Yeah, and this is the relationship that tan A is actually 1 upon cot of A. So this is how you can convert tan in cot. This thing is establishing that they are complementary angles. Actually, you're not expressing tan in terms of cot. Getting the point?
Yes, ma'am.
Okay. All right. Third question now. Sorry, second. Write all the other trigonometric ratios. So one is sec. Okay. So apart from sec, you have to convert every other ratio in terms of sec. So sine in terms of sec, cos in terms of sec, like that. So let's start with sine. Now you have only
Ma'am,
3
can I
items.
just scroll up once?
Sure.
Okay, ma'am.
Right. Second question. So one value is sec A and you have to convert others in terms of sec. Okay, Hamna. So let's start. Now load down whatever identities you have. First of all, there are 3 only. That's sine of A, sine square A plus cos square A is equal to 1, right? Next is 1 plus tan square A is equal to what? Sec square A. And then 1 plus cot square A is equal to cosec square A. So just keep them in mind, like in front of you. Now I want the value of sine, right? So that means I should start with this identity because it is having sine, so that I can get the value of sine from here. So let's start with this. So sine square A plus cos square A is equal to 1, right? So I can just keep the sine on one side. Sine square A becomes 1 minus of cos square A, right? Now can I write this 1 minus 1 upon sec square A, because cos is 1 upon sec, correct?
Yes, ma'am.
Okay. Now you take LCM, so that becomes your sec square A minus 1 and divided by sec square A. So your sine of A becomes under root sec square A minus 1 and divided by sec square A. All right, Rita?
Yes, ma'am.
Yeah, so you have converted sine in terms of sec. Okay, so sine we have got. Now what about cos A? Cos we know it's simply 1 upon sec. So I have expressed cos in terms of sec, right? Now let's move to tan. So if I want to write tan of A, so tan of A is first of all sine of A divided by cos of A. I've already found sine and cos in terms of sec, so I'll directly put the values. So sine of A is this, under root sec square A minus 1 and divided by sec square A. And then cos A is 1 upon sec A, correct? Okay. Now, if I just take sec square A minus 1, and see in the denominator, you have square root also, square also, it simply becomes sec A. And then 1 upon sec A, right? So you have same denominator, so it cancels out. Or you can just, multiply like that, you can see. So you are left with this only. Sec square A minus 1 and divided by 1, and that becomes sec square A minus of 1. So you have also expressed tan A in terms of sec A.
Ma'am, cos and sine are inverse, right?
No, cos and sine are not inverse. Cos is inverse of cosec and sine is inverse of uh, sine theta is 1 upon cosec theta, not cos. And cos theta is 1 upon sec theta.
Okay.
Sine and cos are complementary, not inverse.
Okay, ma'am.
So it's a difference, right? Inverse is something different. Complementary is something different. Any confusion, anyone?
No, ma'am.
Okay. Now what sec we already have. Next we have cosec. So let's try to find the value of cosec now. So cosec is 1 upon sine. You have already found sine, just take it inverse, right? So you need cosec of A now, which is 1 upon sine of A, and sine value you already have. So just take inverse sec square A divided by sec square A minus 1. That is your cosec. Or if you want, like, you can take sec A divided by under root sec square A minus 1, because in the numerator you have square root also and square also. So cosec you have got. Now cot. Cot you are left with. Cot is 1 upon tan. Tan we have already found. Just take inverse. So 1 upon under root sec square A minus 1. Written, all of you?
Ma'am, 1 minute.
Yes, ma'am.
Okay. Okay, I hope everyone has written.
Yes, ma'am.
Okay, so quick revision so far what we have done. See, first of all, try to recall. So inverse relationship, then you have like complementary and identities. So just a recap, that's it. So inverse, that means sine of theta is 1 upon cosec theta. Then we have cos of theta is 1 upon sec of theta, and tan of theta is 1 upon cot of theta. So these are the inverse relationship between trigonometric ratios. Now complementary. So if you have sine of 90 minus theta, that becomes your cos of theta. So sine and cos will be complementary. Then if you have a tan of 90 minus of theta, that will become your cot of theta. So they are complementary. Yeah, am I right? And then sec and cosec you have. I hope I've written correct, right? Cosec theta. Is this okay? Yes. Is this correct? Please match it with the previous formulas you have written in your copy. Now come to identity. So we
Correct,
have,
ma'am.
sorry, Rida.
It's correct.
Okay. So now identity is again 3. So sine square theta plus cos square theta is 1, right? Then you have 1 plus tan square theta is equal to cot square theta. And then 1 plus, sorry, wait. Sorry. 1 plus tan square theta is sec square theta. And then 1 plus cot square theta is cosec square theta. So please, this is the recap of what we have done so far. Let's do question number 3 now. Evaluate first. So you have sine square 63 degree plus sine square 27 degree divided by cos square 17 degree plus cos square of 73 degree. Now with the help of identities, we will try to solve it, right? Okay. Now, first of all, for identity, now you can see here sine square theta plus cos square theta is equal to 1. So this identity is applicable when you have the same angle, correct? Theta. Now here you can see the angles are different. Here you have like 63 degree, here you have 27 degree. So first of all, we try to make the angle same, and also one should be sine, other should be cos. So we can do like this. One of the sine we can convert into cos, no problem. So if I write sine square of 63 degree plus, can I write this sine square of this 27 can be written as 90 minus of 63? Any problem?
No, ma'am.
Yeah. And similarly in the denominator, I can convert one of the cos. So this cos square 17 can be written as 90 minus of 73. degree and plus cos square 73. Any of the cos you can convert. 73 you can write 90 minus 17, no problem. Now this is sine square of 63 degree plus. So sine of 90 minus theta now becomes your cos theta. So that becomes cos square of 63 degree, right? Divided by, again, cos of 90 minus theta is sine theta. So this becomes sine square of 73 degrees and plus cos square of 73 degrees. Now you just compare it with this identity. So theta is same. So that becomes 1. Again, sine square theta plus cos square theta 1. And the answer is 1. Right? Second part. Second part is sine of 25 degree, then cos of 65 degree and plus cos of 25 degree into sine of 65 degree, right? Okay. See, you can again see 25 is actually 90 minus 65, right? So you can convert any of the one. You can convert this sine into cos or this cos into sine, whichever you wish. So I'm writing this sine 25 can be written as 90 minus 65. Yes. And then you have cos of 65 plus. So any of the cos you can convert. Because I'm getting my answer in 65. So here also I'll try to convert this 25. So this 25 can be written as 90 minus of 65 and then into sine 65. Any problem?
No,
Oh,
ma'am.
okay. So this sine 90 minus theta becomes your cos theta. So cos 65 and into cos 65 plus. Now cos 90 minus theta becomes sine theta. So sine 65 and into sine 65, right? So basically now you get cos square 65 degree and plus sine square 65 degree, and that becomes 1. Cos square theta, I mean, you have to mention the identity that cos square theta plus sine square theta is equal to 1. Yeah, written all of you?
Yes, ma'am.
Yes, Hamna, are you here?
Yes, ma'am.
Okay. Fourth question now. Choose the, yeah, third we have done. Fourth, choose the correct option, justify your choice. First, 9 of sec square a minus 9 of 10 square a. Okay, so let us solve it. So 9 is just a number. I can just take it outside, common. So I get sec square a minus of 10 square a, right? Now remember the identity. So 1 plus 10 square a is equal to sec square a. So if I bring this tan square a that side, so 1 is equal to sec square a minus of 10 square a. So basically this becomes 1. So this is 9 into 1. This is 9. So the correct option is B. Justify means you have to show this identity and then it is justified that you're using this identity. Second, 1 plus tan of theta plus sec of theta, okay, multiplied 1 plus cot of theta minus of cosec of theta. Okay, you have to simplify this thing. See, the easiest way of solving questions is, first of all, try to convert everything in terms of sine and cos. Uh, you, I mean, that makes things a bit simpler, and everything will come in common terms. Like in sine and cos, you will get everything. So you can write it like this: 1 plus tan theta can be written as sine theta divided by cos theta, plus sec theta 1 upon cos theta, correct? Now 1 plus cot can be written as cos theta divided by sine theta, inverse of tan, minus this becomes 1 upon sine of theta, right? Okay. Now you can take LCM. So LCM becomes your cos theta. Now here you get cos theta plus of sine theta and plus 1, right? And then here again take LCM. LCM will be sine theta. And then you get sine of theta plus cos of theta and minus 1, right? Yes. Okay. Now what about the next step? What should I do? Okay, one step can be this, that I simply multiply the numerator. Denominator is simply sine theta into cos theta, and I can multiply each term. That is also okay. And I can just convert it here, as I have a square minus b square is actually a plus b into a minus b. Can you compare it with this? So if I take this cos theta and sine theta combined, so this is cos theta plus sine theta plus 1 and cos theta plus sine theta minus 1. So can I write it as a square minus b square identity? Yes, please respond.
Ma'am, both are plus, right?
Yeah, so I'm taking it combined. This is, let's say this is my x. So this is x plus 1 and this is x minus 1.
Okay, ma'am.
Yes.
Yes, ma'am.
So I should get x square minus 1 square, isn't it?
Yes, ma'am.
Yes, Hamna, Rida.
Yes, ma'am.
Yes.
Yes, ma'am.
Okay. Just think of it as some one thing and then see. Don't write x like this. I mean, just to compare, I was showing. So I can write it like this. So that becomes your cos theta plus sine theta whole square and minus 1 whole square and divided by simple multiplication cos theta into sine theta. Any problem? Okay. So let me do it here. And if you don't want to use the identity, you can simply multiply. Just open the bracket and multiply, then also you will get the same thing. Do it carefully. You can check it later on. Now cos, see, this is not cos square theta plus sine square theta. So you cannot write it 1. This is whole square. So you have to open the bracket. So it becomes cos square theta plus sine square theta plus 2 into sine theta into cos theta, right? A plus b whole square and then minus 1 divided by cos theta into sine theta, right? Now this becomes 1. Cos square theta plus sine square theta becomes 1. So 1 plus 2 sine theta into cos theta and minus 1 divided by cos theta into sine theta, right? Now this one cancels out with this. So you get 2 sine theta, cos theta, and divided by cos theta or sine theta, same thing. And then this also cancels out. Answer is 2. So the correct option is second. Sorry, C. C option is correct. Yeah, shall we move to the next?
Yes, ma'am.
Okay. Third part now. So third part is sec of A plus tan of A into 1 minus of sine of A. Okay. Now again, the simplest thing will be to convert it in terms of sine and cos. So this can be written as 1 upon cos A plus sine A divided by cos A. And then you have 1 minus of sine A, right? Now take LCM. So cos A is the LCM, and then you have 1 plus sine A. And here you have 1 minus of sine A. Again, you can see this is A plus B into A minus B. That means A square minus B square. So 1 square minus sine square A and divided by cos of A, right? Now, the identity is this. Sine square A plus cos square A is equal to 1. So if I bring the sign there, so I'm left with cos square A is equal to 1 minus of sine square A. So in place of 1 minus sine square A, I can write cos square A divided by cos of A. So one cos will be gone. Answer is cos of A. Right? Okay, fourth part. Let's check now. This is 1 plus tan square A and divided by 1 plus cot square A. Okay, now again convert it into sine and cos first of all. So 1 plus sine square A divided by cos square A, and then 1 plus cos square A divided by sine square A, right? Now take LCM. So cos square A, and then you have cos square A plus sine square A. And similarly in the denominator, the LCM is sine square A, and then you get sine square A plus cos square A, right? Okay. Now cos square A plus sine square A, that becomes 1. So 1 upon cos square A and then divided by 1 upon sine square A, right? So obviously this one multiply here and this one multiply here. So that becomes sine square A and divide into 1, you can write, or cos square A into 1, right? So sine square A upon cos square A. Now what is sine upon cos? That is tan. So that becomes tan square A. So D is the correct option here. Okay, next question. Fifth one. Prove the following identities where the angle involved are acute angles for which the expressions are defined. So you have to prove them. So the first one is this. Cosec theta minus of cot theta whole square is equal to 1 minus of cos theta and 1 plus of cos of theta. So basically you have to solve the LHS and RHS and they should come out to be equal, or your LHS should come out to be equal to the given expression. Let's start with LHS here. All right. So the LHS is this, that cosec theta minus of cot theta whole square, right? First, I can open the bracket first of all. So this is A minus B identity. So this becomes your cosec square theta plus cot square theta minus 2 into cosec theta into cot theta. Is this correct? This is a minus b whole square. Now you convert it into sine and cos. So that becomes 1 upon sine square theta plus this becomes cos square theta upon sine square theta minus 2 into cosec is 1 upon sine theta and cot is cos theta divided by sine theta, right? Okay, now you can see sine square theta is same, the denominator is same, so the LCM remains sine square theta. So here I get 1 plus cos square theta minus 2 into cos theta, right? Okay, so can I write it like this? See the numerator here. If you compare it with this, a square plus b square minus 2ab. So this can be written as a minus b whole square. Yes, Rida? So this is basically 2 into 1 into cos theta, right? So the numerator actually becomes 1 minus cos theta. Or will it do me some good? Oh, yes, you're right. So this can be written as 1 minus cos theta whole square, right? Any problem here, Hamna?
No, ma'am.
Rida? Harsha?
Ma'am, there the denominator is sine theta, right? It's not sine square theta.
No, it's sine square. See, first of all, I have a
Ma'am,
whole square, right? Harsha,
yes, ma'am.
start looking from here. So this is a minus b whole square. So this becomes your a square plus b square plus 2ab, right? So cosec square will become 1 upon sine square theta. Square will remain. Similarly, this is cot square theta. So this is cos square theta upon sine square theta. And this is like 2 sine are here. So it's actually sine square theta, sine theta into sine theta.
Okay, ma'am.
Yeah. I've
Yes.
skipped one step, like you can write it in the next step as 2 cos theta upon sine square theta, and then you can take LCM. So I've directly taken sine square theta as my LCM. Now see here you have denominator also in terms of cos theta. So basically I have to convert my sine square theta also in terms of cos square theta. So sine square theta is simply 1 minus cos square theta from the identity. Yes?
Yes, ma'am.
1 minus cos square theta from the identity. So I can write it here 1 minus cos theta whole square divided by. Now 1 minus cos square theta can be written as 1 square minus of cos square theta, that is a square minus b square. So I can write it cos square theta divided by, so 1 minus of cos theta into 1 plus of cos theta. Yes, a plus b into a minus b. So 1 power of the numerator will be gone now. Understood?
Yes, ma'am.
So this will give you 1 minus of cos theta and divided by 1 plus of cos theta. So this is equal to RHS. So you have proved. So shall we do one more?
Yes, ma'am.
Okay, I have to rub a little bit. My slides are almost over. Okay, I have one here. Right. Next part also, let's take quickly. Second part. So this is the LHS I'm taking only. Cos A divided by 1 plus of sine A and plus 1 plus of sine A divided by cos of A. Okay, so this you have to show this is equal to 2 of sec A. So let's start working out with the LHS, right? So it's already in terms of sine and cos. That means you have to do simple algebra now, nothing else. Okay, take LCM, first step. LCM will be 1 plus of sine A and into cos of A, right? So that becomes your cos square A plus this becomes 1 plus sine A whole square. Any confusion here?
No.
Okay. So open the brackets, cos square A plus. So A plus B whole square, that means 1 or 1 square plus of sine square A plus 2AB. So that means 2 into 1 into sine of A, right? And then divided by 1 plus of sine A into cos of A. Now this cos square A plus sine square A will become 1. And then you have one more 1 here. So you get 2 plus 2 sine A. So I'm skipping the steps. You can write it. 1 plus sine A into cos A. I hope you have understood, right? Now take 2 common. That's just a number. You can take it out. 1 plus of sine A and divided by 1 plus of sine A into or cos A. So this whole bracket actually cancels out. You are left with 2 upon cos A and 1 upon cos is sec. So 2 of sec A. So that is equal to your RHS. Okay, you can give it a try to the other parts also.
I'm in the last step, we're taking 2 common.
Yes. So try to solve the other parts also. In case you have a complicated RHS, so RHS also you can convert into sine and cos, and then you can show that the both are equal, right? So you can also solve your RHS if required. And if directly you can see it's easy to achieve, then it's okay. So try to attempt. First of all, convert everything in sine and cos, and then it becomes simple algebra, right? Just taking LCM, multiplying and all those things. You just have to do the calculations carefully. That's it. Okay, then we will continue in the next class now.
Okay, ma'am.
Okay.
Thank you, ma'am.
Okay, bye. Thank you.
Thank you, ma'am.
Yes, hello, Sarah, you are here?
Yeah.
Okay. When did you join? Just now?
Yes, 7 at 7.
At 7?
Yeah, for
Oh,
me.
7 for you. Okay, okay, fine. That means not. All right, just a minute. So we were doing triangles, like few questions were remaining. I think 5 questions, 5, 6 questions. Sarah, tell me one thing. Will it be possible for you if I shift you 1 hour before?
Like what?
Like your 6 p.m.? Can you take class at 6 p.m., Sarah?
Yeah.
Currently, you are taking class at 7 p.m. according to your timings, right?
Yes.
So can you take class at 6 p.m.? Will it be fine
Yes.
for you? Okay. So, okay, you will be notified accordingly. You can join, but it might be from the next class. You have
Okay,
to
ma'am.
join at 6. Yeah. Actually, your syllabus is lacking behind. It becomes difficult for me to, bring every student on the same
Yeah.
exercise.
Sorry.
Okay, which exercise we were doing? 6.3, right?
Yes.
6.3, right? Question number 3, 4 we have done. 6th also, I think we have done. No. 6th we have done, Sarah?
Seventh
Yes.
we have done.
7th we have done. Yeah, 8th now. Exercise 6.3, 8th question. Now, E is a point. So this is the figure, first of all, something like this. Sorry, it's so bad. Anyway, this is, okay, this is 4E, sorry, D and C, A, B. This point is F, right? So I'm giving some names to the angles also. Let's take this 3 and this is 1. So E is a point on side AD produced of a parallelogram ABCD. So what is given here, that ABCD is a parallelogram. Parallelogram means the opposite sides are parallel. That means AB is parallel to CD, and also it is given that AD is parallel to BC. That is the meaning of parallelogram,
Yes,
right?
ma'am.
Okay. And BE intersects CD at F. Okay, show that triangle ABE. So you have to show the triangle ABE. Now look at ABE. ABE is similar to triangle CFB. CFB. Okay. So see the triangles in the figure. Now proof. See, this is very easy. When some lines are given parallel, then things become very easy, Sarah, right? Now, if two lines are parallel, for example, like this, right? And there's a transversal cutting it. That means this angle is same as this angle.
Yes.
Yes. Which kind of angles they are?
One minute. Alternate angles.
Exactly. Alternate interior, because they are on the interior sides of the
Yeah.
parallel lines. Now look at this figure again. See here, you have your line CD, right? This is your line CD. And this is your line AB, right? And then there's a line cutting it. So that means this angle is same as this angle, 2 and 1, right? Yes, alternate interior angles.
Yes, ma'am.
Okay, so you can write that since CD is parallel to AB, so angle 1 is equal to angle 2. Alternate interior angles. And similarly, you can say that line AE, now look this side. Now ABCD is a parallelogram, Sarah. So basically
Yeah.
AD is parallel to BC, right?
Yeah.
Now AE is actually AD produced. So AE is AD produced. Like if we just extend this line, so it becomes AE. So if AD is parallel to BC, then obviously AE is also parallel to BC, right?
Yes.
Yes. So this complete line AE, it's parallel to BC. Now this is a transversal. So that means your angle 4 is equal to angle 3, correct?
Yes.
So therefore angle 4 is equal to angle 3. Same, alternate interior angles. Okay. Now, if you look at these triangles now, so in triangle ABE and triangle CFB. Okay, so two angles are now same. I have angle 1 is equal to angle 2, and I have angle 3 is equal to angle, angle 4 is equal to angle 3.
Angle 3.
Yes, so by AA criteria, your triangle ABE is similar to triangle. Now name it carefully. So when you have A, my figure is really messed up. Wait.
I have it in my.
Okay. So this is like A, B, C, and D, E, and F, right? So
Yeah.
this was actually my angle 1, and then this was my angle 2, right? So when I'm having B, so that means at the point of B, I should have F, because angle 1 is equal to angle 2. So F should come in the middle. Got it?
Yes, ma'am.
Yes. And then I have angle 3 is equal to angle 4. So when I have B, I should have E here. So if I have E here, I should have B here, and then C. So CFB. So that's the correct naming. Got it? So have you written?
No, I didn't know it.
Just a minute. I have it written. Okay, please complete.
Done.
Okay. Next question now. Question number 9. So it's a figure like this. Okay, in the given figure, ABC and AMP are two right triangles. Okay, ABC. So that means this angle is 90°, right? And AMP. So that means this angle M is 90°. Okay. Right angled at B and M respectively, prove that this. So given that these angles are 90, and you have to prove this thing first of all, that triangle ABC is similar to triangle AMP, right? First thing. And then second, you can see in your book, you have to show that CA upon PA is equal to BC upon MP. So let us look at these two triangles and let's see what do I have, which criteria we can fulfill. So in triangle ABC and triangle AMP. So first of all, we name the triangle which we are taking. Now you can see from here also AA is common, right?
Yes.
So angle A is part of both. See the figure also, ABC and AMP. So angle A is equal to angle A, which is common. Yeah, think of the other one also. Just give me a minute, Sarah.
Okay.
There's a call, important one. Yes, Sarah.
Yes, so angle B is equals to angle M, and they both are 90 degrees.
Yes, but I cannot write it B because this is not the vertex of the triangle. So I can write angle ABC like this
Yeah,
is equal
is
to
equals to
angle
angle M.
AMP like this. Not angle M. See, if you have something like this, the corner angle, then you can write it angle B, no problem, right?
Hmm.
But B here is not a corner angle because I can understand this angle also. How will you
Yeah.
differentiate? Yeah, so that you have to name ABC. Okay. Yeah, so the triangles have become similar by AA criteria. So ABC is similar to AMP by AA
AA
criteria.
criteria.
Okay. Now, next part of this, you have to show this CA upon PA. Now, first of all, see which side is CA. CA means this side, right? And
AMP.
PA means this side. Okay. And BC upon MP. So that means this side upon this side. So this is simple. Now, because the triangles are already similar, their sides, corresponding sides are in the same ratio. Or you can see from here also, Sarah, like second part. Now, because ABC is similar to triangle AMP, right?
Yes, ma'am.
This we have shown. That means this side AB is proportional to AM, right?
Yeah.
Okay. See here, I don't have AB. Look here, I don't have AB. So just leave AB. You see this one. You see this. BC is proportional to MP. Can I write it?
Yeah.
So that means BC upon MP is equal to, and this last corner ones, AC upon AP, right? So I can write AC upon AP. Yes.
Yes, ma'am.
Okay.
True.
Now what you need, Sarah, here you need CA. CA means AC, right?
Yeah.
Upon PA. Yeah, so you are getting this
True.
BC upon MP. So this is proved. So like without looking at the table, like from here only you can write this thing, right?
Yeah.
Okay. So please note I'm erasing it a little bit.
Just leave the second part.
Mm. Hello.
Yes, ma'am.
Yeah, sorry, Sarah. Okay.
Question 10.
Now, yeah, you have done it. So let's move to the next question now. So please read question number 10. Okay. Question number 10 now. So CD and GH are respectively the bisectors of angle ACB and EGF, right?
Yeah.
So basically there are two triangles here, Sarah. So A, B, and C, and then you have E, F, and G, right?
Yes, ma'am.
So CD and GH are bisector of angle ACB. So that means this is angle ACB. So CD is the bisector. So this implies that this angle is equal to this angle, right? So
Yes,
I
ma'am.
can, okay. And similarly, this is the bisector H. So that means this angle is same as this angle. So bisector means it divides the angle into two equal parts such that D and H lie on this. Okay, respectively. Now something is given here.
Yeah. Triangle ABC, similar to triangle FEG.
Yes, triangle FEG. And then you have to show this thing. To show CD by GH is equal to AC by FG. Okay. ACD, ACD, ABC. Okay. Now look here, Sarah. What you have to show, like look here, you have to show that CD by GH. Okay, you are given ABC similar to FEG, right?
Yes, ma'am.
Okay, now what does it imply? If the triangles are similar, so that means the corresponding sides are in the same ratio. So that means AB upon EF, right?
Yeah.
Should be equal to BC upon FG, right?
Yeah.
Should be equal to AC upon EG,
FG.
correct? Okay. Now see, FG or EG?
EG.
EG, yeah. Okay. Now see, you have to get where is CD by GH, AC by
Number
FG,
9. Number 9. Shouldn't it be BC by EG?
BC by EG.
No.
Mm,
Because it's like 1, 2, 3, 4.
FEG. Okay, I've made a mistake here, Sarah. If I look at the name only, like I was looking at the figure. I think I made a mistake. Now look here, AB should be proportional to FE, right? I should
Yeah.
write it like this. So AB should be equal to EF or FE, right?
Yeah.
Okay. And then you have BC upon EG.
EG.
Yes, you are right. And then AC
Upon FG.
is, yes. So now it is correct. So basically AC by FG, which I need to show, I'm getting it here, right?
Yeah.
But I'm not getting CD by GH here. For CD by GH, CD is this middle line and GH this middle line. So at least I have to show half of the triangle similar to half of the triangle so that I can get this side. Correct?
Yeah.
Okay. So I'll try to take these angles now. So if I want to show the first part here, let's take triangle ACD, right? And triangle FGH, right? I mean, this side ACD and this side FGH I'm taking. Any problem?
No, ma'am.
Okay. Now, what do I have here? Also, because this was given that they are similar, so that implies that angle A is equal to angle F, right?
Yes.
From the terminology, I can say angle A is equal to angle F. And I can say, yeah, I can also say that angle C is equal to angle G, right? That means half of angle C is equal to half of angle G, right?
Yeah.
And half of angle C, if I
Right.
call it 1 and if I call it 2, so angle 1 is equal to angle 2, right?
Yes, ma'am.
So basically now I have angle 1 is equal to angle 2, which I have proved separately. And then angle A is equal to angle F. So two angles I am getting same here. So that means the triangles are similar. Therefore, triangle ACD is similar to triangle FGH, right? Yes, Sarah, by AA criteria. Now, because the triangles are now similar, the corresponding sides are in proportion. So this implies, now you look here, so AC upon FG is equal to CD upon GH is equal to AD upon FH, right? And you only need this much. CD by GH, that means this term and this term. Or you can say that AC by FG is equal to CD by GH, correct?
Yes, ma'am.
Okay. Okay, now let's do the second part now.
This one. Done, ma'am.
Okay. Second part now. So second part, you have to show that CD by GH is equal to AC by FG, right?
Yes, ma'am.
Okay.
But it's already proved.
No, it's already proved. Yeah. Second part we have done. No, what we have to show is oh, I'm sorry. Second part. This was first part. I wrote it wrong. Sorry. The second part is triangle DCB is similar to triangle HGE. This you have to show, Sarah, right?
Yeah.
Now, first of all, see which are the angles here. So DCB means this one, and HGE is this one, right? Okay. So one thing again, as now because it is given that triangle ABC is similar to triangle EFG, right? This is given FEG. So what does it imply? Because I need these pink triangles this time, so I have to take angle B is equal to angle E. So this implies that angle B is equal to angle E, correct?
Yes.
From the name also I can see. Okay. And then again, I have angle C is equal to angle G, and half of angle C is equal to half of angle G. And this time I'm interested in the pink triangle, so I need this angle. So I call it 3 and I call it 4. So that means angle 3 is equal to angle 4, correct?
Yeah.
Okay. Now take these two triangles. So in triangle DCB and triangle HGE, which you have to show similar. So what do I have now? Now I have angle 3 is equal to angle 4, and I have angle B is equal to angle E. So again, by AA criteria, the triangles are similar.
Yeah.
You can write. Okay. Now third part. Right, written, Sarah?
This one. Done.
Okay. Third part, actually, we have already shown, right? Actually, we have taken it a bit different. ACD and FGH, we have already shown that they are
Yeah.
similar, right? So same way, you can just take rename the triangle and show they are similar. Angle 1 will be equal to angle 2, angle A is equal to angle F, and the triangles are similar.
Yeah.
Actually, we started with part 3 in this case. Okay, let's move to the next question now, 11th. Sarah, can I take one extra class tomorrow for you?
Yeah. At what time? Yes, at what time?
Your mm, do you have school these days?
No, I'm on holiday.
Holiday. So can we have it in the morning?
Like what time?
Oh, okay, let's keep it, I think, according to you, 5 p.m. Is that okay?
Yeah.
5 p.m. your timing. That means mine 6:30.
Yeah.
So let's have a class at 6:30. I'll just try to finish coordinate geometry with you
Okay, ma'am.
because that chapter is already over in my batch. And yeah, because you know, I cannot take more separate classes. I have to merge this batch. That's why. So let's have a class of coordinate geometry tomorrow. Let's try to finish triangles now. 11th
ma'am.
question. In the given figure, see the question carefully. E is a point on side CB produced of an isosceles triangle ABC. So you have an isosceles triangle ABC. Okay, what is an isosceles triangle?
With two sides equal.
Equal, good. So this is D. So this side is actually produced, right? E. And then, okay. With AB is equal to AC and AD is perpendicular to BC. That means this is 90 degree. And EF is perpendicular to AC. So this is also 90 degree. And then you have to show, so to show that triangle ABD is similar to triangle ECF, right? And this is given that AB is equal to AC.
Yes.
Okay. Proof. So one hint is here itself, Sarah, when it is given that AB is equal to AC, so that means angle B is equal to angle C, right?
Yes.
Angles opposite to equal sides. Okay,
And
so
angle
this,
ADB is equals to angle EFC.
yeah, so in that case, first of all, you have to name the triangle which you are taking. So in triangle, so take the triangle ABD and triangle ECF, right? Okay. Now see, this I have written from this only, which is given. Now I'm taking the triangles. Now in these two triangles, I have angle B is equal to angle C. And yeah, which you are saying that angle ABD I'm taking. ABD means I have to take this angle. ADB, right?
Yes.
Okay, is equal to, then triangle ECF is this one. So I'll take the triangle here, let me call it F. EFC. Now two angles are equal, therefore they are similar. So triangle ABD is similar to triangle ECF by
Yeah.
AA criteria.
Then
Okay. Next question, Sarah. PQR. Okay, read the question.
since AB and BC AB and BC and median AD of a triangle ABC are respectively proportional to side PQ and QR. And median PM of triangle
Okay,
PQR.
yeah, so side AB and BC and median AD of a triangle are respectively proportional. So median, first of all, they are saying median. What is a median?
That line, the
Yeah,
middle
if
line.
if AD is median, yeah, so what does it mean? So we have altitude, right? Altitude means that if let's say this is
The
my
height.
line. No, altitude means, let's say CD is altitude on AB. So altitude means this angle is 90 degree, correct?
Yeah.
What is the meaning of median? Okay,
And
let's say I have this angle AB, right? And I'm saying that CF is the bisector of this angle. So that means this angle is equal to this angle. So similarly, there's a meaning of median also. What is the meaning of median? Median is something which divides the opposite side into two equal parts. From median, from middle point, you can remember. Median means middle point. So that means D is the middle point of BC. Understood?
yes, ma'am.
That means it is given that BD is equal to DC. Got it?
Yeah.
Okay.
Um,
Okay. So first of all, it is given that BD is equal to DC, and it is also given that QM is equal to MR because they are median. So this thing is given. Next, it is also given that AB is proportional to PQ. So AB upon PQ is equal to BC upon QR is equal to then AD upon AD will be proportional to PM. So if you read the question, so this is given. Now you have to show that triangle ABC is similar to triangle PQR, right?
yeah.
Okay, let us do it. Okay, so ABC is similar to PQR. So exactly what you want to show, Sarah. Basically, you want to show, if you see from here, you want to show that AB by PQ, right, should
Yeah.
be equal to BC by QR, should be equal to AC by PR,
Yeah.
right? Now, what is given to you? AB by PQ term is there, BC by QR term is there, only this term is different, AD by PM, right?
Yeah.
If you somehow convert this AD by PM into AC by PR, so you get the required thing, right?
Yes, ma'am.
Okay, so we will proceed it this way. Let us start from here, which is given. So it is given that AB by PQ is equal to BC by QR is equal to AD by PM, right? Okay.
Yeah.
If I do it like this, AB by PQ, and I'm dividing it half. in the numerator and half in the denominator. No problem.
Yeah.
Same number I can divide and multiply.
Really
Okay.
bad thing.
Now AB by PQ. Now what is half of BC? So half of BC can now be written as BD because D is the AD is the median, right?
Yes.
So half of BC is actually BD now. And
By
similar,
QM.
sorry, half of QR will become QM.
QM. Yeah.
Okay. Is equal to AD by PM. Right?
Yes.
Okay. Now, which triangle is this? So this is the side AB is proportional to PQ, right?
Yeah.
Then BD, that means this is proportional to this. And
Mhm.
AD means this is proportional to this. So basically, these two triangles are coming out to be similar from here.
Yeah.
So this implies that triangle AB and
D.
D, okay, will
Yeah.
be similar to triangle PQM.
QM.
Good. So like this small triangle I have shown to be similar, right?
Yes, ma'am.
Okay. Now, because the triangle are similar, so this implies that angle B will be equal to angle Q,
Yeah.
right? Corresponding parts of similar triangle that you can write. Okay. Now, because ultimately, Sarah, two sides I already have proportional. If somehow I get the middle angle also equal, then SAS criteria I can write to show similarity.
Yeah.
So basically that angle I have got from here, right?
Yes, ma'am.
So instead of full triangle, first of all, I have shown that these small triangles are similar. Now, because they are similar, so that means this angle I have got to be equal to this angle. Now, again, come back to the full triangle, right? So
Ma'am.
in triangle ABC
And
and
PQR.
triangle PQR, yes. Now, two sides I already have, which is given that AB by PQ is
Is
equal
equal
to BC by
BC by
QR.
QR.
This much is given to me. Now, you again see carefully, AB is this side and BC is this side. So the angle has to be this one, which falls between these two lines. So angle B is equal to angle Q, which I have proved. So by SAS criteria, the triangles are similar. ABC is similar to triangle PQR.
Done, ma'am.
Okay. Next question now. Sorry, actually, I didn't get the time to stop the class in between. Otherwise, my slides would have started fresh.
Mm.
All right. Question number 13 now.
Mm.
So D is a point on side BC of a triangle ABC. So there's a triangle ABC here. A, B, and C. D is any point here. Such that angle ADC, that means this angle, is equal to BAC. Okay, this complete angle, right?
Yeah.
So this is given that angle ADC is equal to angle BAC.
BSC.
Okay. Show that. So you have to show that CA square is equal to CB into CD. This point means into CD, right?
Yes, ma'am.
Okay. Let me take these two triangles now. Which one? If I take triangle ACB, full ACB, right?
Mm.
And triangle DCA. DCA. So let me try to show them similar first of all. Now in these two triangles, if you look at, so this
Angle
complete,
C.
yeah, angle C is common, very good. Angle C is equal to angle C, and one thing is given, that angle ACB means angle BAC is equal to DCA means angle
ADC.
ADC. So this is given and this is common.
Common.
So by AA criteria, the two triangles are similar. ACB is similar to triangle DCA by AA criteria, right?
Yes, ma'am.
Okay. Now because they are similar, so what can I write? I can write AC divided by DC is equal to, then I can write CB divided by CA, right? And
Yeah.
then I can write AB upon AD. Yes, this much I can write from here.
Yes, ma'am.
Okay. Hmm. See, this AC or CA is the same thing. So I can write this as, because in the, to show I have CA, right? Not AC.
Yeah.
So I can convert. So I can leave this part. This, I mean, this much is not required. I'm taking only the first two and I'm writing this AC as CA. So CA upon CD is equal to CB upon CA.
Yeah.
So in the same things like I've written CD, CB, like that I'm writing. So just multiply, like take this CA here. So this is CA into CA and take this CD here. So CB into CD and this CA into CA becomes your CA square is equal to CB into CD. So proved.
Ma'am, you did cross multiplication there.
Yeah, cross multiplication. So I'm multiplying, yeah, this CA together and these CD and CB together, this cross multiplication.
Done, ma'am.
Okay.
40.
14th question, Sarah. Side AB and AC and median AD of a triangle are respectively proportional to this. Okay, it's a good question. Let me just erase it. So you have a triangle ABC, Sarah. A, B, and C. Then there is another triangle. Let's take PQR. AB, AC, and median AD. So that means you have a median also, which is AD and PM. So there's median PM here. Median means BD is equal to DC and QM is equal to MR, right? Okay. So what is given? That AB upon PQ is equal to, then you have AC upon PR and median AD. Okay, so that means AD upon PM. So
Yeah.
this is given. Okay. Show that. You have to show that triangle ABC is similar to triangle PQR. So we have just done another question like this. The question number 10, if you remember.
Yes,
No,
ma'am.
no, sorry, 12. Right. So in 12,
Yeah.
yeah, we need to show that the triangle ABC is similar to triangle PQR, and here also we need to show. Now, what was given in 10? It was given that AB by PQ is equal to AC. So that's the difference. No. Don't you think it is the same question as question number 12? What is the difference?
Mm, I think we have no. No. D is the midpoint.
Okay. The difference is this, Sarah. In the question number 12, the sides were proportional like this, you know, AB by PQ, right? Was
Yes.
proportional to BC by QR,
Yeah.
right? And here it is AB by PQ, but not BC. The AC side is proportional to PR. This side is not given here. In that question, actually, this side was proportional to this side. It was given, correct?
Yeah.
But here in this question, this side is given and this side is given. Got it? That's the difference now. Okay, just see here, difference, Sarah. This was actually question number 12, right? This one. So question number 12 was that, Sarah, that it was given that AB by PQ, right?
Yes, ma'am.
So AB by PQ was given to be BC by QR. It was given that BC by QR. So what we did, we take these side like AB and BC, and then we have shown this middle angle to be equal, so that we have used SAS criteria. Understood?
Yeah.
Because they were already given equal. But in this question, it is not given equal. This side is not in proportion. It is given that AB by PQ is equal to not BC. It is given that AC by PR. Getting the point here?
Yes, ma'am.
Yeah. So in this case, we need to show angle A to be equal to angle P. Getting my point?
Yeah.
Because the angle has to be the middle angle. So if these two sides are proportional, then I have to show this angle to be equal. So in the previous question, we have shown that angle B is equal to angle Q, and then we used SAS, right?
Yeah, ma'am.
Now here, because these two sides are proportional, so I need to show that angle P is equal to angle A, and then I can say SAS criteria. So that is the difference. I hope it is clear.
Yes, ma'am.
Okay. So obviously the approach is going to be different here. Let us think. Okay, so what do you think we should do?
Um,
So
in
here,
triangle,
no.
D is the midpoint, right?
Yeah, D is the midpoint. Yes. So it's a bit difficult, Sarah, because the question number 12 was easy. Here the approach will be very different, because you have to show angle A to be equal to angle P, right?
Yeah.
Here actually you need to do one construction before proof. Why? I'll just explain. First of all, you draw DE parallel to AC. This is E, right? And I'm drawing a line again, which is parallel, MS, which is parallel to PR. So draw DE parallel to AC and MS parallel to PR. Why I'm doing this, Sarah? Now, if you remember the midpoint theorem, what is the midpoint theorem, Sarah? From the previous classes, we have studied a midpoint theorem. The theorem is this. Now, please again revise it. I have a triangle, right?
Yes, ma'am.
Okay. And if this, let's say D is the midpoint, right, of BC. This is a triangle ABC. If D is the midpoint, I draw a line from D which is parallel to BC and it meets AC at E. So basically D is the midpoint and I'm drawing DE which is parallel to BC, right? So midpoint theorem says that E is also the midpoint of AC. Understood?
Yeah.
So the theorem is this. Again, just recall the theorem. Theorem is this, that if you have a triangle and you take any midpoint here, from this midpoint, if you draw a line parallel to the other side, that means parallel to BC. So wherever it strikes, this is also the midpoint. Understood? So that means E is also the midpoint.
Yes, ma'am.
This is the theorem. So this theorem we are going to use here. Okay. Now take this proof now. Now take triangle ABC. In triangle ABC, right?
Yes, ma'am.
Now D is the midpoint of BC. This is actually given to us.
Yes.
Okay. And then we have the line DE parallel to AC, like by construction. This is given. All right. So I can say, therefore, E is the midpoint of AB. How can I say? From midpoint theorem. Understood? Now E is the midpoint of AB. So we can say that, yeah, and also there's a theorem, Sarah. Now I have got that E is the midpoint of AB, right?
Yeah.
Now there is again a theorem, Sarah. If these two are midpoints, right? And this line is joining them, for example, DE, and this is BC. So the length of DE is actually half of BC. This theorem you also studied in the class 9th.
Yeah.
It's called which? Okay. E is the
Yes, ma'am.
midpoint of AB. So you can write that DE is half of AC. So can you see in the figure, DE is half of AC?
Yeah.
Okay. Same thing we can do for the other triangle also. So we will not do the whole thing. We will simply write similarly. Okay.
Yes, ma'am.
Similarly, we can say that SM is equal to half of PR. So one triangle we will show, other we will write similarly, SM is equal to half of PR. Right?
Yeah.
Okay. Now come back here, which is given to us. So this much we have shown so far. You can call it result 1 or result 2 if you wish, just to give it some name. Now start from here, which is given to us. Now it is given that AB by PQ is equal to AC by PR and is equal to AD by PM, right? This is given. Okay. Now AB, can I write AB twice of AE now? Because E is the midpoint.
Yes.
Okay, AE. And similarly, PQ I am writing twice of PS. Right?
Yes.
And now similarly, AC, I can write twice of DE because I have shown in result 1.
Mm.
And then PR, I can write twice of SM. Yes?
Yeah. And
Okay.
AD and PM is the same.
And AD by PM is same. Okay. Now you just remove this 2. So what you get, AE by PS is equal to DE by SM is equal to AD by PM, right?
Yeah.
Now without looking at the figure, if you want to write from here, so that means triangle. So AE, right? AE will be similar to triangle. So AE should be proportional to PS. So that means PS has to come here, right?
Yes, ma'am.
And then DE has to be proportional to SM. So E is here, that means D has to come here, and then M has to come here. So triangle AED. Now look at triangle AED in the figure, which is triangle AED. is this one, right?
Yes, ma'am.
And PSM is this one. So we have shown that these two triangles are similar. All right.
Yes, ma'am.
Now, because the angles are similar, so therefore this angle will be equal to this angle. Yes.
Yeah.
If I give some name to it, let's give it some name. Let me call it angle 1 and let me call it angle 2. Right?
Yeah.
Or 1, 2 I keep for this triangle and then 3, 4 for this. So let's say call it 3. So angle 1 is equal to angle 3. Therefore, corresponding parts of similar triangles, right?
Yes, ma'am.
Okay, so this I have done for this triangle. Now the same thing I can do, like I can do a construction on this side, right?
Yeah.
And then I can show that angle 2 is equal to angle 4. So there is no need of repeating the whole procedure. We will again write that similarly. You just give name, this is 2 and this is 4 very carefully. So we can prove that angle 2 is also equal to angle 4. Yes.
Yes, ma'am.
Similarly, we can do it. So 1 we have shown to be equal to 3, right?
Yes, ma'am.
Okay, so I'm erasing a little bit. Have you written?
Yeah.
This much you have written?
Yes.
Okay, right. All right, let me give some name to this equation. Let me call it 3 equation. Let me call it 4. So simply add. So adding equation 3 and 4. So if I add, so I get angle 1 plus angle 2 is equal to angle 3 plus angle 4, right? Now angle 1 plus angle 2 becomes your complete angle A
Good A.
and angle P.
P.
So far, Sarah, I have only shown that angle A is equal to angle P, right?
Yeah.
Okay. Now come back to here. Now it was already given, Sarah, that this side is proportional to this, right?
Yeah.
And this side is proportional to this. Now we have shown that angle A is also equal to angle P. So SAS criteria, these two triangles are similar, right?
Yes,
So
ma'am.
we will write in triangle ABC and triangle PQR. Now I have, this thing is given to me that AB by PQ is equal to AC by PR, right? These two sides are given. And the angle between these two sides, we have shown that angle A is equal to angle P, which is proved. So by SAS criteria, triangle ABC is similar to triangle
PQR.
PQR by SAS. Okay, one last question is remaining. Let us just complete it very quickly. It's a small one.
No, ma'am, there are two.
Yeah, I mean, there are small questions.
Just 1 minute. Done.
Okay. Okay, read the question till then. Yes, done. Now, question number 15, quickly, it's easy. So a vertical pole of length 6 meters, right? So there's a pole, Sarah. Let's say the length is 6 meters. Cast a shadow 4 meter long on the ground. So it is making a shadow here, which is 4 meter long, right?
Yeah.
On the ground. Okay. So like up till here, the shadow is being formed. And at the same time, a tower cast a shadow 28 meter long. So obviously the tower will be on this side then, right?
Yeah.
So I have a tower here and it is also casting a shadow, and the shadow of this tower, basically the length from here to here, this is 28 meter, right?
Yeah.
Find the height of the tower. So this height you have to find. So you just join them, make a triangle and give it some name. Let me call it AB, and this we can call ABC, and then we can call it
DE.
DE, PQ, whatever you want. Okay. Now, if I show that triangle DEC is similar to ABC, then the corresponding sides will be proportional, right?
I'm sorry.
Can I show, let's say, in triangle ABC, I take the full triangle, right? And I
Mm.
take this small DEC. I want to show them similar. Can I show them? Because
Yeah.
angle C common in both.
They are 90 degrees.
Yes, because poles are exactly vertical, right? It is also given the vertical pole. So that term is important. Vertical means it is given that this angle is 90 degree. Understood?
Yeah.
Okay. So I can write angle ABC is equal to angle DEC, which is 90 degree each. So they are similar. So therefore triangle ABC is similar to triangle DEC. Now
By
because they, yeah, by AA criteria. Now, because they are similar, the corresponding sides will be in proportion. So that means AB upon DE should be proportional to BC upon EC, right?
yeah.
Okay. So this implies now AB you don't know, you have to find AB, and DE you know, which is 6 meter, and then BC length
28.
28, very good, meter, and then EC
4.
yeah, 4 meter, yes. So you get AB should be equal to 6 meter into 28 meter and divided by 4 meter. So 1 meter will go, and 4 into 1, 4 into 7, and 6 into 7 is how much? 42. So this will be
Yeah. 40 centimeters.
42 meter. See,
Oh
1
yeah.
meter is it remaining, so 42 meter. Okay. Okay, one last question. Let us take it very quickly. If AD, PM are medians of triangles, so again you have two triangles, Sarah, ABC, and AD is the median. Similarly, you have another triangle, PQR, and then PM is the median. Where, okay, this time it is given that triangle ABC is similar to triangle PQR. So if you remember in the previous question, we were proving that these triangles are similar, right?
Yeah.
And this time it is given that this complete triangle are similar. In question number 10 also and in 12 also, we were trying to show that the triangle ABC is similar to PQR. All right. Now what you have to show, Sarah? Okay. So to show,
AB by PQ is
yeah,
equal to AD by PM.
AD by PQ is equal to AD by
By
PM.
PM.
Okay. Now, if I start from the given condition, Sarah, look here. Now, what is given to me that ABC, triangle ABC is similar to triangle PQR,
PQR.
right? So
Yeah.
that means like I can write that AB is equal to PQ, right? Is equal to BC is equal to QR, and then you have AC upon PR. This implies this thing, right?
Yeah.
And I'm interested in this AB by PQ, that means first term. Okay. Now, BC and BD, there's a relation between this term and this term. So I'll just ignore this term. So I'll take the first two. So AB by PQ is equal to BC by QR, right? Now, because it is given that D is the median, so I can write AB by PQ is equal to half of BC divided by half of QR, right? Half I'm doing. Now half of BC will become BD. So AB by PQ will become BD by QM, right?
Yes, ma'am.
Okay.
Mm.
And also because the triangles are similar, I can say that angle B is equal to angle Q. Yes, this also I
Yes,
can say.
ma'am. Yeah.
So now if I take these small triangles, like this one, that triangle ABD, the left one, and this left one, and triangle PQM, right?
Yes, ma'am.
So now I have got AB by PQ is equal to BD by QM, which I have proved from result 1, you can say, already proved. And then I'm getting angle B is equal to angle Q. So by SAS criteria, triangle ABD will be similar to triangle PQM.
There are two types of chromosomes.
Understood?
Yes, ma'am.
Okay, and if they are similar, then again the corresponding sides are also similar.
Yeah.
So I can write AB by PQ is equal to, so from here I can write, AB by PQ, and I need AD by PM. So the corner ones I take, so AD divided by PM, right?
Yeah.
Okay, proved.
Amir is having two types of chromosomes and Y chromosome. And female is having
Done, ma'am.
Okay, so the other exercises are not coming in the exam, they are omitted in the CBSE syllabus.
Yeah.
So only 6.3 you have to do up till 6.3. And so tomorrow you will be notified, Sarah. Please join on the time. The office will send you the link, and we
Okay,
will be
ma'am.
having an extra class. So